Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the longifulin, and as we know that longifulin, it is an natural product, how it is useful as a medicinal point of view, and that's why we are considering the synthesis of longifulin. And in our previous lecture we have discussed the retrosynthesis of longifulin, how retrosynthesis of longifulin can be done, that we have seen in detail, as well as there are 9 different ways to synthesize the target molecule, which is a longifulin, and we just started the first ways of synthesizing that longifulin. If you remember, yesterday's lecture we have taken as a starting material is a valent macellar, that is there are 2 carbonyl group, one is a alpha beta unsaturated and one is a isolated carbonyl group, and there we have treated that compound with the A reagent. The reagents are considered or taken as such as 1-diol, 1,2-diol. Second reagent we have added modified Wittig reagent, followed by osmium tetroxide, and another one is a TSCl, and we got finally the structure. And this structure further treated with the B reagent now, as we know that the longifulin. So we are studying or discussing the scheme number first. Let us see here the B reagent, first one, that compound further treated with base, and second one it will be treated with acid treatment is given, and what type of the product it will provide. So yesterday we have seen this type of the compound. There, let me recall that compound so that you can get idea about that. This is a starting compound which we have taken, and here we have added as a reagent, one is this one, diol, then second will be the compound modified Wittig reagent pH3, CpH3p double bond CH/CS3. Second one we have added osmium tetroxide OSO4, and the fourth one we have added TSCl, tosyl chloride. And by adding these reagents we have got the product like this. Here OO, this is a methyl group, and here we got the double bond over here OTS and hydroxyl group. This double bond remains as it is. This type of the product we have got if you see carefully here, the 1,2-diol, which is a protecting group which will protect the carbonyl group, which is more reactive. If you compare the reactivity of this carbonyl group is alpha beta unsaturated, and therefore the reactivity of that carbonyl group is less, and this is a isolated carbonyl group, and that isolated carbonyl group in this particular case, that isolated carbonyl group has greater reactivity toward the 1,2-diol, which is a protecting group which get protected like this. Then further it is treated with modified Wittig reagent. After adding modified Wittig reagent, it is a regioselective compound. We will get here the double bond. Outside the double bond we are getting as a olefinic, means conjugated diene we are getting, and after getting as a conjugated diene, again it stereoselective reaction. Osmium tetroxide, it is a oxidizing reagent, and it generally produce cis hydroxylation. It is known for cis hydroxylation, but here there is a two competitors are there, two carbon-carbon double bonds are there, and which are then they are in a conjugation. One is outside the ring, one is inside the ring, and the carbon-carbon double bond which is outside the ring, which is less hindered in nature, and therefore cis hydroxylation takes place at the less hindered side selectively. Cis hydroxylation it gives, and again then that cis hydroxylation further treated with tosyl chloride. Again the question arises, there are two hydroxyl group, they are present at 1,2 position, that is a vicinal diol. Now one is a tertiary alcohol and the another one is a secondary alcohol. Again one of the hydroxyl group get converted into good leaving group, tosyl group will replace one of the hydrogen atom from secondary alcohol, not from the tertiary alcohol. Remember, again the steric hindrance plays an important role here in this particular case, and therefore stereochemically it is preferentially attacking or replacing the secondary hydroxyl group of the hydrogen atom get replaced by tosyl group, and we are getting this type of the product. Up to this we have discussed in our previous lecture. So right now here this is a B reagent, OH minus and H plus H2O. This reagent when we are adding, there is a pinacolan type of the rearrangement reaction takes place or occur, and the resulting compound will be obtained like this. Let us see here, there is a skeleton rearrangement reaction takes place. The OTS, that pinnacle rearrangement, the possibility or the reactivity of that pinacolan rearrangement is enhanced due to the presence of tosyl group, and the resulting compound will be formed. The 6-membered ring is converted into as a 7-membered ring like this, and finally this H plus in presence of the H2O, it is a mild, means what we can call it as a mild acidic condition is Consider here for the deprotection of this carbonyl group, it get generated back due to this, and you will get carbonyl group as it is, one methyl group which is there, which also remains as it is, and here we are going to get the alpha beta unsaturated compound, and at this position methyl group, this is the carbon number 1 which is there, and this will be the carbon number 10, and as we know that, and this is a carbon number 7, then 6 5, likewise 6 5 4, then 3 2 1 1 2 3 4 5 6 and 7, like this, and here there is a 10. And now when this compound further treated with, observe this reaction carefully. When this reaction, this compound, when reacted with the, here C I am writing here, Et thrice N triethylamine at 225 degrees centigrade at a higher temperature, this condition is maintained here to get the desired product. The product obtained, that is a triethylamine, and temperature is kept is very high, 225 degrees centigrade. The photocyclo addition type of the reaction takes place, and you would get here the product like this. This is a general compound which we are going to get over here. One methyl group, it remains as it is. Now this carbonyl group which is attached to the 6-membered ring as it is, and here are the one methyl group which is there, and at this position which is a carbonyl group present over there. So this is the compound which we got over here, and as we know that this is a bridge side is a 7, and this is nothing but as a carbon number 10, and carbonyl group that is at 11. Here is the only one CS3 group, here also has a CS3 group. Now if you observe this structure carefully, and this compound further treated with the reagent D, which is PH3CLi and methyl iodide. Predict the product, or what type of the product do you get if you see the structure over here, triphenyl methyl lithium or triphenyl lithium, which is a very strong base. What it will do, it will abstract the acidic proton from here, form as a carbanion, and that carbanion is going to attack on that methyl group. In this way, the methyl group is introduced at a particular position, at a proper position, where we can see in the target molecule there are 2 methyl groups are there, and therefore by adding as a D reagent such as triphenyl lithium and methyl iodide, the methyl group is easily introduced at this position, and the compound will be formed like this. So this is the structure which let me draw that structure first properly. Here we will draw this structure like this. So here is a methyl group, carbonyl group is here, and this carbonyl group, it remains as it is, only changes are occur at this center, which is a reaction center, where there is another methyl group is introduced at that particular carbon atom, which we can required in our longifulin, which is a target molecule which we are trying to achieve here by this first method, so that we are discussing now this compound now further treated with here B, C, D, and here is a E. First one, thiol I am going to use here, CH2, CH2SH, that is a thiol 1,2-thiol in presence of Lewis acid BF3, which is a Lewis acid, which will enhance the reactivity of that carbonyl group, means that carbon atom becomes as a more electrophilic in nature, and therefore nucleophile can attack at this carbon atom readily and form as a thioketol. So that is the speciality of this reagent. Now second reagent used here is a lithium aluminum hydride, LAH. It is known as lithium aluminum hydride, which is a good reducing reagent, strong reducing reagent. And third reagent used here is this one, then hydrazine in presence of OH minus. It is one of the well-known reagent. You can tell me the reagent and just heat it. After heating, what do you get? The resulting compound here. Let's see each of the reagent, how they are utilized, how they can play their role in this particular reaction, that is a thiol in presence of the Lewis acid. Now there are the two competitors are there, two carbonyl group. One is a hindered carbonyl group and one is a less sterically hindered, and therefore preferentially or selectively this thiol protecting this carbonyl group and form the thioketol. The reason behind it, it is a less hindered, and if you see this carbonyl group which is highly hindered, and therefore this carbonyl group selectively get protected with this reagent, and the resulting compound form is known as thioketol, thioketals. That is a cyclic ring, and that's why we are calling such type of the compounds are thioketals. Now after that we are adding lithium aluminum hydride, and everybody knows that lithium aluminum hydride, it is a strong reducing reagent which will reduce. See, the functional group is this one carbonyl group. This is a carbonyl group get reduced by lithium aluminum hydride, carbonyl group get converted into secondary alcohol over here, and after that see the reagent here. Can you tell me, do you remember H2NH2OH? It is one of the reagent which is synthesized by one of the famous scientists. The name of that scientist is Wolff-Kishner reduction. If you recall some other general reaction when carbonyl group is converted into as a hydrocarbons, there you can see Clemmensen reduction, which is used in acidic medium, which will convert the carbonyl group into as a hydrocarbon. The reagent used in Clemmensen reduction is zinc amalgam in presence of hydrochloric acid in a basic medium, which is a Wolff-Kishner reduction, and the reagent used such as hydrogen hydrate in presence of base like as a sodium hydroxide or maybe potassium hydroxide. The carbonyl group get converted into hydrocarbons, and in a neutral media or in a neutral condition, one of the reagent is used as thioketols or 1,2-thiols in presence of ranitidine gives the carbonyl group into as a, or convert the carbonyl group into carbohydrate, and these are the general information you can remember as far as there is a conversion of carbonyl group into as a hydrocarbon. These are the three different medium used to convert carbonyl group into as a hydrocarbon. And now after adding these reagents, the final product will be the product obtained here will be this one. Let's see how we can draw. This is a general way of writing this type of the compound. One methyl group which is here. Here are two methyl group which we can write as it is, but this carbonyl group gone from there because that carbonyl group is converted into as a hydrocarbon, means CH2, and this due to that lithium aluminum hydride that get into as a reduction, and finally this is a this carbonyl group further get converted into as a hydrocarbons, and that's why we got as a this type of the product. This is a secondary alcohol now, and when this treated with the reagent which we are going to employ here, we are going to use here, which is a F, and F is nothing but the reagent first one Cr chromium. The oxidation state is shown as a 6, means this is a oxidizing reagent, and what it will do, it will convert secondary alcohol into as a carbonyl, followed by second reagent which is CS3Li, that is a methyl lithium. Methyl lithium is going to attack on that carbonyl group, similar to as a nucleophilic addition reaction, then followed by acid treatment. There is a dehydration of water molecule takes place, and the resulting compound form will be our target molecule. And as we know, the target molecule is this one, now which we have drawn here. Methyl group here is a CH2, these two methyl group, and this is nothing but our target molecule, which is a longipholene, which is a target molecule which we have achieved, we have derived. And this is the first synthesis. Such a type of the, still there are the 8 different ways, different path to achieve, to synthesize these target molecules. And therefore, let us see some of the important steps which we have seen over here. Let's see. The synthesis was carried out as shown in the scheme number. This is a scheme number 13.24. A diol was formed and selectively tosylated at the secondary hydroxyl group, that is represented in step A4. Base then promoted the skeletal rearrangement in step B1 by a pinnacle rearrangement. Here pinnacle rearrangement takes place, and there is a ring expansion is carried out over here. 6-membered ring becomes as a 7-membered ring, which is known as pinnacle rearrangement. When there is a 1-2 diols are present, then and then pinnacle rearrangement occur. So that type of the rearrangement taking place over there, and we got this type of the product here. Corresponding to 23 second to 23 third in the retrosynthesis. And in the retrosynthesis, while an retrosynthesis, as we know that an imaginary but logical reverse chemical reaction which convert a molecule into a possible starting material, and that type of the backward reaction we have seen in the retrosynthetic analysis. The key intramolecular Michael addition, as we know that Michael addition, intramolecular Michael addition takes place at alpha beta unsaturated carbonyl group. It is preferentially or selectively nucleophile attack at carbon-carbon double bond rather than the carbonyl group. The key intramolecular Michael addition was accomplished using trimethylamine under high temperature condition, triethylamine at 255 degrees centigrade are, and then the cyclization requires that the intermediate have a cis ring fusion that is the speciality of this reaction. The stereochemistry of the ring junction was established when the double bond was moved into conjugation in step B2 here. The product was not stereochemically characterized and need not be, because the stereochemically important site at C1 can be epimerized under the basic cyclization condition. Thus, the equilibrium of the ring junction through a dienol allows the cyclization to proceed to completion from either stereoisomers. After the crucial cyclization in step C, the subsequent transformation effect the addition of the remaining methyl and methylene groups by well-known methods. Step E accomplishes a selective reduction of one of the two carbonyl groups to a methylene by taking advantage of the difference in the steric environment of the two carbonyls. Selective protection of the less hindered C5 carbonyl was done using a thioketone. The C1 carbonyl was then reduced to C11, not the C1, C11 carbonyl was then reduced to give the alcohol, after which C5 was reduced to a methylene group under Wolff-Kishner conditions. The hydroxyl group at C11 provided the reactive center necessary to introduce the C15 methylene group via methyl lithium addition and dehydration in step F, which is shown over here. The Wieland Michler ketone was also the starting material for the synthesis in scheme 1325, and that scheme also is represented in a well-mannered by considering the well-known methods, and we can easily achieve the target molecule, which is a longipholene. I think this is a first scheme we have seen with the appropriate explanation. The second scheme which we are going to take as an starting material is a Wieland-Michler ketone, which is a starting material, and that Wieland-Michler ketone can be obtained by, that is a Robinson annulation, and which is one of the key intermediate used for the synthesis of that Wheeler-Michler ketone. I think this is enough explanation regarding the scheme number first. Tomorrow we will consider the second scheme, starting from different starting material which are available, readily available, and how we can carry out the reaction in a different reaction condition by taking different reagent and what are their roles. With the help of explanation or the description, we will see that scheme number second in tomorrow's lecture. Let us stop today here. Thank you. Have a nice day.